Good evening, everyone. Apologies for the delay, and we'll start with today's class. We had done a lot of algebra and combinatorics, I think, previously. We'll start with some geometry. Try this question out. Two circles of two congruent circles pass through each other's centers. Find angle CED uh, from the figure. Okay. AB is the radius of both of the circles, and CB and AD are diameters of both the circles. Find the angle CED. Once you get the answer, you can put the answer in the chat.
Sir, is my answer correct?
Okay, Vaibhav and Yashraj have answered correct answer. Okay, and I'll In case anyone wants more time, you can put wait in the chat or unmute and you can let me know. Or else I'll start with solving this. Anyone wants me to wait? Okay. Uh, See, the simple thing to do over here is do some constructions. You can join A to E. I'll not draw it here.
So is my answer correct?
And BE can be joined. It is quite trivial that all these are radial segments and they all will be equal. This makes EAB a equilateral triangle and you know all the angle lengths inside it 60, 60, 60. And these two become two isosceles triangles with the vertex angle being 120 degrees. So the base angles become 180 minus 120 divided by 2. So this becomes 30 and this becomes 30. So total angle CED equal to 30 plus 60 plus 30, which is equal to 120. Okay, any doubts? Okay. Try the next question, it will be a bit more challenging. A square and a regular pentagon have a square is located inside a regular pentagon as follows. Okay. They share a side. Okay, I'll give you the figure. Okay, this is the figure. This is a square and a regular pentagon. Both share the share a same side. Find angle ABC, where A, B, and C are the vertices of the pentagon and square respectively. Obviously, you need to join C and B. Find ABC. Akshita, try again. Not correct. Now, Akshita, still not correct. Try again. Answer is actually smaller than the first one. Sumit, correct. Adrija, try again. Yashraj, correct. Okay, those who are done with question 2, you can try this question.
Any more information provided?
Vaibhav, correct answer.
Sir, any more information is provided in this question?
So
Okay, should I
70
start discussing?
centimeter.
Anyone wants me to wait for question two?
So
Still
70
someone?
square centimeter is the area of the interior semicircle.
Just a second. Now someone said try saying something. I'll possibly be able to.
So is 70 square centimeter the area of the inner semicircle.
It's the area of inner semicircle. Now I can hear you guys. In question two, is there any doubts? Okay, there is one isosceles triangle that you need to identify. Uh, what is the interior angle of a regular pentagon? Angle AB. Let's call this point D because it will be very useful. Uh, I'll bring all of this bonus question stuff below. Okay. This angle is 90 degrees. Interior angle of regular pentagon is equal to the angle sum property. The angle sum property for regular pentagon is 3 times 180 degrees. Divide by 5. You will find that this becomes 108 degrees. Why 3 times 105? Because you can split the pentagon into three triangles basically, and each of those triangles have 180 degrees in their interior. They all will add up to become the interior angle of your pentagon. And since all interior angles are equal for a regular pentagon, it will be whatever this product is divided by 5, and it's 108 degrees. So we know that this angle is 108 minus 90 equal to 18 degrees. And we have an isosceles triangle over here. BCD is isosceles. So the base angles over here will become 81 and 81. Because 180 minus 18 divided by 2 is equal to 81. And this remaining angle over here will be 108 minus 81, which is equal to 27. Is it fine? No doubts, I hope. Everyone can keep working on the bonus question. Till then, I'll give you another question to solve. Okay. In triangle ABC, DE and F are on sides BC, CA, AB, such that you get the following ratio for BD is to CD. Once I make the figure, it will be more convenient. Okay, this is the ratio of the side length BD is to CD, X and 2X. Area of GEC. this triangle here, its area is 3 and the area of GCD is 4. Find the area of the entire triangle ABC. Here you can use that the fact that two triangles having the same height will have their areas in the ratio of their bases, or two triangles with the same base will have the area in the ratio of their heights.
Is my answer correct?
Akshita, not correct. Try again. Sorry, correct. Correct answer. Try the bonus question again. Yashraj, try again. Bonus, Sumit, the shaded area you have not found correctly. Try again. Sumit, you have to find area of shaded region. Uh, all this included. If you have found answer for that, then answer not correct. Iman, what's the doubt? Anyone wants me to wait? Iman, what is your doubt? Have you sent your doubt anywhere? Sumit, not correct. for both questions. Okay. What I meant by the hint over here is that suppose you have uh,
Area of triangle BEC is equal to 15.
area of triangle BEC.
15.
This, correct. And that solves the question, but wait for me. It doesn't solve the question completely. Yeah, it is correct. So you have 4 over here. This will become twice the area, so it becomes 8. 8 plus 4 plus 3 is 15, yeah. But you have to
15.
find the area of triangle ABC. Okay. So yeah, I'll explain the hint. Suppose you have two parallel lines. The general statement is that triangles between two parallel lines have the ratio of their areas with the ratio of their bases. Because two parallel lines fixes the this is triangle 1, this is triangle 2. You could have such a setup where these two triangles are uh, having are between two parallel lines. You have another setup where you could possibly make the triangles like this. Okay, here they share the common base. So they are going to have the same area regardless of where this vertex is. Because height is always same for both these, for any of these triangles. Uh, Another setup could be to have common vertex over here, and this is base B1 and B2. This is triangle 1, triangle. So in all situations, the ratio of the areas is simply the ratio of the base, and that is easy to figure out. Yashraj and Sumit, not correct. Try again. Abhyuday, not correct. So, Iman, I hope your query is resolved. What I'll do is I'll give you an equation to start with. You can possibly solve the rest. Obviously, this is twice the area of this GBD. Will have twice the area of GDC because they share the common vertex. That means these are two triangles between the same set of parallel lines. Base are in the ratio 1 is to 2. So area will also be in the ratio 1 is to 2. Now, what you can do is, this is where, unlike most questions, I will be doing a deconstruction. I'll be removing this length F and G so that it becomes more clearer to visualize what is happening over here. You can notice in this triangle over here, again, there are lots of ways to do the same thing. Uh, Ratio of these two triangles are in the ratio of the uh, base length, correct? If you notice, these two triangles are between the same set of parallel lines. What happened?
They both are congruent.
They are not congruent. They have same they have area ratio in the ratio of their bases because again this is two triangles having a common vertex. That means they have the same height. Okay, they are on the both base lengths are on the same straight line. What that actually helps us do is you can see that the same thing is true for these two triangles also. Uh, Basically, what I can write is area triangle ABG because that is what you want to basically find upon area triangle PGC is equal to AE by EC. This is hint number 2. This is what you can use. There are other ways to do it also. Reason for that is I'll just make another figure over here. A, B, C, D, and E. Let's call this X. Then BD by DC is obviously area of triangle uh, ABD divided by area of triangle ADC. It can also be written as area of triangle XBD over area of triangle XDC. And it can also be written as the area of triangle ABX over triangle ACX. Here it's not like congruency that you need to worry about order of the vertices that you're mentioning over here. What I'm trying to say is every type of triangle on the left side and this corresponding triangle on the right side, if you take their area ratio, that will be equal to the ratio of the areas of the two bases over here. Why it is the same for these two triangles also is because you are removing proportional parts out of proportional stuff. This big triangle is to this triangle is proportional to this triangle is to this triangle. So if you remove them in proportion, then you get that these two remaining bits are also in the same ratio, which is BD upon DC. Iman, correct answer. Okay.
Excuse me, sir.
Yeah.
So you told that triangle AGE is not congruent to triangle CGE, but I took both are congruent, so their areas are
Uh,
same.
i- i- if you take them to be congruent, then you assume something that assumption ended up being actually correct and give you the answer. But it is not necessary that these two triangles are congruent. In fact, in most cases, they won't be congruent. The only case where they will be congruent, see, the thing is in the question, although it's not given, you can prove it that AE is equal to EC. Okay. Once you show that AE is equal to EC, then everything is done. That this upper triangle has the same area as this bottom triangle, and you add them up, you get 30 as the answer. Okay, then question is solved. But in most cases, even though they are equal, these two triangles are not necessarily congruent because nothing is fixing the position of this G. You can take this A and move it as much as you want around. You will find that these two triangles will have same area, but never in general congruent. I can suggest you guys to use GeoGebra geometry calculator, where you can like position these vertices and then you can like make these constructions and then you can take this point A and you can move it around and you can see how your triangle deforms. You can then visually see that these two triangles necessarily don't need to be congruent always. Sometimes they might be congruent if you just make triangle ABC as an isosceles triangle and E is the midpoint over here. Only then these two triangles will become congruent. Without that, it won't be possible. Okay. So this hint too, if we focus over here and we continue, I'll do one thing. Keep this aside. Let's call this one, this as some length. We can just assume this is some alpha, and this is y alpha. So basically we have y upon 1 is equal to this triangle AGE will now have area 3y. Similarly, the area of triangle ABG will be 12y. Is this fine? This triangle will have y times the area of this one, and this triangle will have 12y times the y times the area of this entire region, which is 12y. Now, if you notice triangle ABD and ADC, these two should have the area ratio in the ratio of the bases. So you get 12y plus 8 divided by 3y plus 3 plus 4 is equal to 2x upon x, and solving this you get 12y plus 8 upon 3y plus 7 equal to 2, and 12y plus 8 equal to 6y plus 14, or 6y equal to 6 and y equal to 1. You can also see it from here that this is 12y and this is 3y plus 3. They are also double of each other, and then this gives us y equal to 1, and the area of the entire triangle becomes 30. Okay. So anyone having issues with this question? So far, I think only one of you has answered it properly. Vaibhav, correct. And who else? I think only Vaibhav has answered. Okay. Try this next question. Similar logic you have to apply. Don't overthink this question. So ABCD is a square. P is one third the way. Uh, I mean, it's not one third the way. It's quarter of the way across the diagonal DB. So DP is 3 times PB, and PF is then a perpendicular dropped from the point P to the side BC, and to VF is equal to FH. Basically, what you are getting now, these two triangles after joining the points PC and AH. So APC, sorry, APQ, this triangle area minus this triangle area, you have to figure it. Even I'm not sure when the results of AMC 10 will be published, but it should be about 3 to 4 weeks after the exam. So you can expect the result around first week December, second week December.
Excuse me, sir.
Yeah.
So like PF is 1 by nothing is written in the denominator.
No, PF is perpendicular to BC. I'll Now is it clear?
Yes.
PF is perpendicular to BC, and FH is equal to FP. Sumit, very good, correct answer. Sumit, keep working on this area problem. You have done a little bit of circles, na? You know. Okay. Yashraj also correct. Yashraj, are you done with this problem?
No,
Not
sir.
yet. Vaibhav, once you are done, let me know. I will.
Instruction is required, na?
Here, question 4 or
Or
bonus?
bonus.
I mean, a little bit of construction is required. Obvious constructions only. Nothing out of the ordinary. Uh, Even this area is 12, 70 square centimeter. Hi, I mean the colored area only. Okay, before I start discussing, anyone wants me to wait? The thing is about this question. The position of P doesn't actually matter. Here it is given that PB is one third of DP, which makes it one fourth of the way across the diagonal or halfway between these 2 points. You can then use some amount of coordinate geometry, and here you can take that this is side length of 100. You can actually figure out the areas of both these triangles, but that won't matter. Always the answer will be the same. It doesn't matter where point P is. So you can just simply place point P anywhere you like and figure out the general area of these two triangles uh, and the general difference. Uh, One thing. Second thing, notice something special about this line segment PH. PH is always parallel to AC. Once you show that, question is done. Okay, try to show PH is parallel to AC. Sumit, not correct. Achha, even for this bonus question, I'll give a pretty simple hint. Use this. These are two equal lengths because they are the radii of this smaller semicircle. And this is the radius of the larger semicircle. This all I am writing 90 degrees from symmetry only. You can join this segment also over here. There will be two triangles. There is no reason to actually have either of these triangles unequal because I know it's not given in the question, but these two semicircle, their bases are parallel to each other. It's visibly parallel. So apart from that, nothing else is required. Symmetrically, you can observe that this radii is perpendicular to this base, and this forms the isosceles right triangle. Web correct answer. Okay, I'll start solving this. Anyone wants me to wait? Let me know. Okay. Okay, everyone just stop working on the problems. If you are done with this question, then leave it. This triangle is an isosceles right triangle. I hope everyone agrees. Because the diagonal of a square divides the square into diagonal of the square bisects the angle into 45 degrees. And this angle also becomes 45 because this is perpendicular. One angle is 45, other will be 45 also. Similarly, over here, this triangle is congruent to triangle PHF. Triangle PFB is congruent to triangle PFH. Now it doesn't really matter how I order P and H or P or B over here because they are isosceles right triangles. Why are they congruent? Because common side, common other side, and sandwiched angle between them is congruent. So by uh, SAS congruency, these two triangles are congruent, which gives us one very important angle, HPF. Notice something that PF is obviously parallel to AB, and these two lines, AC and PH, are equally inclined to a set of parallel lines. Can you see that these two angles are like equal and the base is parallel? So the other ray uh, will be also parallel. Yashraj, very good. Correct answer. So, and that is all we require. Uh, this gives angle HPF equal to 45 degrees. And from here, we get AC parallel to
So Sumit,
PH. Yeah, Sumit, not correct. I don't know, Sumit, where you're going wrong. Because once you do this, it becomes that the area of this small semicircle is half the area of this large semicircle. Correct. And then you just
the answer 140. I gave the answer 140 much earlier.
no. So shaded region is this na. So
The
you remove
shaded
the
region
shade.
is 140 minus 70.
I thought that you have done it properly, but then you didn't respond at that time. No issues.
First answer was wrong, but second answer I gave 140. That I didn't subtract.
Then it's correct. So, but you should be getting the same answer again and again. Na? So get stuck and then ask, okay, why is it wrong? So I'll just write the reason why these two are parallel. Uh, they are parallel because how should I put it? Uh, line segment equally inclined to a set of parallel lines. Of course, there is one issue with this type of reasoning, because you could have that these are two parallel lines. I have one line going like this, another line going like this. Even though these two angles are equal, that doesn't mean that these two lines are parallel to each other. So they have to be equal in the same sense. Okay? If you are going clockwise, then this also should go clockwise. And it's more about like visually seeing and using it rather than writing a full proof for it, because this is more of an objective question only. AMC8 is an objective exam. So you can rely on your instincts uh, when it comes to geometry. You don't need to completely prove it. So these two become parallel, and now you can use all the facts related to triangles between parallel lines. These two triangles uh, have the same base, same height, so same area, and QPH is the common triangle between these two triangles. If you remove that common triangle area, you are left with the two triangles in question, and the difference of them will become zero. Okay, so I'll move the bonus question out over here. Area APQ minus area BCQH is equal to area AHP minus area CPH, because I can add this common region to both of them. So I get AHP and CPH, and these two are equal to each other as area AHP equal to area CPH. So it doesn't really matter on where point P is. This will always be zero. Did someone actually figure out the two areas? No one figured it out. This HCH will be half of this point. Q will be, we can figure it out, but I'll not do it right now. But uh, I think the it would be 25 times, no, 20 times 50 divided by 2. So I think approximately 500. Someone can check if you got the same result. I'm not 100% sure. Okay. Bonus question. I am now discussing it. You have this as one of the radii, this is the other radii. This is the radii of the larger semicircle. If this is R, this is R, this is R, and this is root 2 R from Pythagoras theorem. Area of small semicircle equal to half pi R square. Area of large, and this is equal to 70. Okay. Large semicircle equal to half pi capital R square, and capital R square is 2 of small r square, half pi small r 2r square, which is equal to pi r square or 140. So shaded area equal to pi r square minus half pi r square, which is equal to 7. Okay, once you are done with this bonus, you are probably fit to attempt this next bonus. Okay, so those who want can keep attempting the bonus question. Till then, attempt this question. Attempt question 5 first. If you are done with question 5, I'll reveal the bonus question. ABCD is a convex quadrilateral. AD is root 3. Angle AD are given. I'll wait 1 minute before I actually give you the figure. Try to make the figure on your own.
Excuse me, sir.
बोलो.
Sir, I wanted to ask, like, there was something about the property of the 30, 60, 90 triangle, right?
That won't be of very much use over here, but you can use it.
Okay.
Okay, okay. It will be of use. If you want, I can make the triangle for you.
In this question, we haven't got any right triangle. We have just got a trapezium.
Uh, I mean, initially it feels like there won't be any right triangle, but eventually you will find the right triangle. Draw the figure with AD on the base. That will make it more simpler. So I'll make the figure for you guys. We have, let's consider this as the base AD.
So is it a whole number?
No, answer is not a whole number. Yes, Raj, try again.
Sir, is my answer correct?
Akshita, not correct. Everything inside root or the 2 is
Everything
outside?
inside the root.
Not correct. Try again. I'll give 2 minutes before I make a very crucial construction, after which you can easily see what's happening.
The trapezium.
Okay, of course, this is a trapezium, but that is not really useful. What will be more useful is like extracting a parallelogram out of it. I mean, make a construction such that you get a parallelogram. Akshita, still not correct. Try again.
So that is made.
Made a parallelogram.
Yes, I made a parallelogram, but no benefit of it.
Vaibhav, not correct. Try again. Achha, this question can be easily solved if you take a limiting scenario. See, always in objective exams, you don't need to go and prove stuff. If AB plus I is missing over here.
Therefore,
AB
objective
plus
it could be easily solved.
so at least get the answer initially. Akshita, correct. Very good. So AB and CD you can assume equal and equal to AD. That gives you a parallelogram basically. Opposite sides are equal, and if the pair of sides that are parallel to each other uh, are actually equal, then you get a parallelogram instead of a trapezium. That is easy to see. If you have a trapezium, this is usually how you would draw a trapezium. If this side is equal to this side, that means K, this is what is happening. And if the pair of opposite sides which are parallel are equal, then the quadrilateral is not a trapezium, it's a parallelogram.
Sir,
And if you assume that
correct?
AB equal to CD, what happened?
So my answer is correct.
Last answer is correct. If you assume AB equal to CD, since it is not given that we cannot assume that. So just assume it. What you get is M is the midpoint of BC. You get a parallelogram. Just find the distance of D to the midpoint of the other side. It will be very easy to calculate. Nothing extra to do. Then we can go ahead and actually prove it that the point M is a fixed point in space. Our dm length will always be constant because it doesn't matter where B and C are, because AB plus CD is equal to 280. Okay, I'll give you 1 more minute to find the answer, prove it on your own. After that, I will solve it. 3 more minutes. You can take some.
Can you please show the bonus question for once? I will take the
Ah.
Sir, taken.
Before we had ended AMC 8 classes few months ago, I had given this one question. I have also sent the link for the the notes. The notes I've sent it on the meeting chat. You can get it from there. All the previous questions that we had done are all available in there. At the end of the class, should we discuss this today or do you want me to discuss it next week? Because this will become a weekly thing, you know.
So now it will be held every week.
I'm not 100% sure. I'll verify. You will get to know anyways from TLPs. Okay, this is the bonus question. Okay. First I'll make the sort
This
of
question will end up in getting a room bus and
A rhombus with all sides equal.
Yeah.
So this becomes root 3. This
Root.
becomes 2 root 3 divided by 2. So it becomes basically root 3. And root 3. This diagonal is also root 3. You can check that for yourself because this is 60 degrees. And an isosceles triangle with vertex angle 60 degrees means that it's an equilateral triangle. So uh, all the new stuff I'll put in red.
Is my answer correct?
Root 3.
Where is my answer correct?
Vaibhav correct. Sumit, Vaibhav correct. Yashraj, check once again. You've done tiny error. And you need to find DM. A, B, C, D. And it is easy to see that this is also an equilateral triangle because once you have established that this is a parallelogram, all opposite sides will be equal. This is also root 3. Diagonal is root 3. And this is the height of your equilateral triangle because altitude, median, angle bisector, everything are the same. Even perpendicular bisector is the same. So this becomes root 3 times root 3 upon 2, which is equal to 3 upon 2. Okay. Now this figure should actually give you idea for making the construction in this figure. What you should try to do is uh, along the length AB. This is not the question figure. No, what you should construct over here is that construct a parallel line. Let's name it EF. Construct EF parallel to AD such that AE equal to AD, and this implies EF is equal to AD and DF is equal to AE because of as quadrilateral ADFE is a parallelogram. I hope that is easy to see. You construct the line segment EF parallel to AD such that AE is equal to AD, and then F point is on DC extended such that EF is actually parallel to AD. This makes that this quadrilateral is a parallelogram. This was the assumption. If you put B on E and C on F, our assumption holds true and you get the midpoint M over here. Now, what you can do with this assumption is that notice this like this figure. I'll keep it over here. Notice that in triangles EBM and triangle in triangle EBM and triangle FCM, you can notice that CF and EB are actually equal lengths.
So
CF
can we
equal
have
to
the bonus question once?
That is my answer for the bonus.
bonus. Akshita, not correct. Try again.
The fraction of shaded by total.
Fraction of shaded upon total. Okay, where were we? In these two triangles, you have to see that these two are actually congruent triangles. Why? Because CF equal to EB. Why is that so? Because AE plus EB plus DF minus CF is equal to twice of AD, which actually means uh, twice of AD, because AE is equal to AD is equal to DF. Okay, this is a rhombus with uh, which means all sides are equal. All sides are equal, hence I'm saying rhombus. So twice of AD plus EB minus CF is equal to 2AD, which gives us that EB minus CF equal to 0, which means CF is EB. So these two corresponding sides are equal. Another thing to notice is that this angle is 60 degrees. Moreover, you can also notice that we have established these two are parallel. EB and CF are parallel segments. They are parallel and they have the same length. So by vertically opposite angles, these two angles are equal. These angles are equal by alternate interior angles. These angles are also equal by alternate interior angles. Basically, what you have is these two line segments. They are parallel and equal. So BFCE forms its own parallelogram, correct? Because these two are parallel line segments which are equal. So they form their own parallelogram, which means that these two triangles are going to be congruent. Uh, Quadrilateral BFEC is a parallelogram as CF parallel to EB and CF equal to E. So we get directly triangle EBM congruent to triangle FCM. So we can write these two are equal. This side length equal to this. Now I did not ever mention that this M is the midpoint over here. I mean, in this figure, at least I have not marked M as a midpoint. I just made that point M on the segment BC. It turns out that this point is the midpoint because EM or this, whatever this point of intersection is, let's call it X. EX equal to XF. So it happens to be the midpoint, and you have very clearly shown that the midpoint M is the midpoint of line segment EF also, and ADFE is a rhombus, which you know quite well to have two equilateral triangles inside it. And then it becomes the same as this figure, this M midpoint. It becomes solving for the midpoint of your rhombus only. And as we did below over here, uh, I can remove D and C now and make it E and F. And you know very easily that dm is equal to 3 by 2. Okay, you can keep working on bonus question then. Vaibhav, done with the bonus? Done taking screenshot of bonus. I hope.
So can you please give a hint for the bonus?
This requires you to here also you have to make a lot of constructions. Uh, First will be this. Hmm, This is all I can give as hint. This is one radii. This is another radii. This is perpendicular drop down here, and this length is the same as this length for this length. Basically, you have to use wherever possible. Any line segments you are getting, they are equal to the radii of the either the quarter circle or the radii of the semicircle. Like this is the small r you can consume. This is capital R. Based on that, you get lots of relations. Here you'll have to use some tiny amount of trigonometry, basically sine 45. Apart from that, nothing else is required. Or you can just use the fact that in an isosceles right triangle, the ratio of sides is 1:1 root 2. That is the maximum that is required. Nothing else. Okay. In line with the bonus question, try question number 6. Uh, okay, this will be today's final question. Okay. This is a sector, circle is tangent at 3 points to sector with interior angle 60 degrees. Find capital R upon small r. If capital R is this length and small r is this length. Small r is the radius of the circle, capital R is the length of is the radius of the larger sector area. Is the question clear? This is very much like you putting a semicircle के अंदर circle या semicircle के अंदर uh, how was the figure going? Something like this. Or you put a semicircle inside another. Here I am putting a circle inside a pizza slice. Uh, to be more precise, a medium size pizza slice. Vaibhav, not correct. See, Vaibhav, answer will be a fraction now over here. Between answer will be between 1 and 0.
Sir, how is it tangent and 3 points? Sir, that part is arc, no?
Arcs are a tangent. So the basic concept of tangent over here, you understood or should I explain more?
Sir, understood.
Understood. So like this circle is going like this, another
Understood.
circle
Sir, understood.
touching at one point. I know I've not done anything else related to circles, but this is more of an intuition based question. Uh, for now, once I give you the concept, it will become just application. Akshita, very good, correct answer. So after 2-3 minutes, you can possibly explain what you did.
Sir, the fact that I didn't solve the question. I imagined something and it just,
Fine. Like at least we can see how good your intuition is. I'll give 2 minutes. After that, I'll make a very, very important construction. After that, question is solved. Not very much remaining.
For me,
Sumit, not correct. Vaibhav, correct. Sumit, what did you do?
right?
What did you do?
Sir, I just draw that connected the center of the circle to the and to the point of this triangle.
This one.
The vertices of the triangle.
Oh, this, you did this.
Yeah.
But it's not a triangle, na. This is a sector. See,
But
everyone might be doing.
but for tangent we have to draw tangent like that now.
So you made a tangent like this.
And yeah, for that I took it to be
Acha,
60,
okay,
60,
okay,
60.
okay. ठीक है, fine, fine. You are on the correct path. But that I have a faster way to get the answer. Okay, 1 more minute. After that, I'll give you guys the answer. I give you guys the hint, which will be easy to get the answer.
Now is it correct?
Sumit, not correct. Acha, the crucial construction that is required over here is that the points of tangency of these two arcs and the center of these two circles are actually collinear. First, use this fact blindly. If you use it from your intuition, fine. From here, you can figure out small r upon capital R or capital R upon small r. I'll give you the proof why this is true in the next class. You can think why it is true. If someone knows the answer, then you can let me know right now. If no one is able to find that, then in the next class I will reveal. Vaibhav, what are you asking? Correct, correct. This length is capital R, correct. Because it is also the radii of the sector.
So it is just similar to like saying that if we put a circle in an equilateral triangle, then connecting the midpoint, that is the point of tangency, to the opposite vertex will be a straight line.
Correct. So basically, what Sumit you are saying is the in center midpoint of the opposite side and the vertex. These will be collinear because this is the angle bisector. Is that what you're saying?
Yeah.
ठीक है, fine. Your
We
perspective say it is completely
we
correct.
can just take it as an equilateral triangle and
This is midpoint of a equilateral triangle. This is in center of a equilateral triangle, and this is
and
vertex. So that is one way of seeing it. Yes, Raj, correct answer. Another way is, okay, since we have already one solution, I'll give you mine also. Uh, line uh, perpendicular to the tangent at point of tangency. Uh, line perpendicular to the tangent at the point of tangency passes through the center. So this circle ka center is this one. This hypothetical circle or the sector or this arc corresponding center is this point. So if you have a common tangent, those common tangent ka perpendicular line will pass through both the centers, which makes these 3 points collinear. And once they are collinear, you have this as R, this as R. This and forget about this R. This entire line segment uh, from the center. 1 second. From here to this point, this will be 2R because this becomes a 60-20 90 triangle, 60-30-90 triangle, and this is R. This makes it 2R. So your entire capital R becomes equal to 3R. So answer becomes 3. Any doubts over here? Anything you want to clarify? Okay. Attempt the few previous questions. Any of you who have joined like for the first time, we have done about 40 pages of material over here. I'll update this.
So number theory.
Link. No, not number theory. We did combinatorics. We did a little bit of algebra, ratio and proportion, and then now we are doing. This was combinatorics.
Combinatorics. So
Then we did a little bit of ratio proportion in algebra. And then I had given this final question, which was unsolved. Today I won't solve it since most of you might not remember it. Attempt this next class, we will discuss this. Okay, it's part of the notes, and then after that geometry starts. Okay, we'll see each other next week or next to next week whenever the classes are scheduled. Bye everyone.
Okay, so.